Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see one more problem which is based on second property of definite integral. Let us start with problem number 9. Integral 0 to pi x into sine cube x into cos square x dx. Here we can use the property of integral 0 to a f of x dx is integral 0 to a f of a minus x dx. So we have replaced x as pi minus x. This will give you integral 0 to pi minus x into sine of pi minus x the whole cube into cos of pi minus x square dx. In the previous video also we have seen sine of pi minus theta gives you sine theta, but cos of pi minus theta will give you minus cos theta. So let us substitute these two values in this integral. Therefore, here we have sin x the whole cube and minus cos x the whole square will give you cos x the whole square, as square of negative sign will become positive. Now let us multiply sin cube x and cos square x with both the terms present in the bracket. This will give you integral 0 to pi times sin cube x cos square x dx minus integral 0 to pi x into sin cube x cos square x dx. In the first integral you can take pi constant outside, and in the second integral this is the original integral I. So let us replace this part by I. If we take minus I on the left hand side, this will give you I plus I, that is 2I. Now let us take this as I1 and solve it separately. Therefore I1 is equal to integral 0 to pi sin cube x into cos square x dx. Considering above equation as 1, as we are going to substitute the value of I1 in equation number 1 only. Here sin and cos are in product form. Therefore we need to substitute one part as t so that the other part will become dt. But here you can see we cannot consider any of this one as directly t, as if I substitute sin x as t, we need only one cos x, and here we have two cos x, that is cos square x. And similarly if I put cos x as t, we will need only one minus sin x, but here we are having three sin x, that is sin cube x. So let us try to split sin cube x as sin square x into sin x, and further that sin square x can be converted directly into cos using the identity, that is sin square x plus cos square x is equal to 1. So we have written sin cube x as sin square x into sin x dx. Now let us write sin square x as 1 minus cos square x using the identity sin square plus cos square is 1. So we have integral 0 to pi 1 minus cos square x into sin x dx. Here you can put cos x as t, as only one sin x is present in the last part. Substitute cos x as t. As we are substituting in definite integral, we need to change the limits also. Therefore let us write the limits of x and t. The limits of x were 0 and pi. To find the limits of t, we are going to substitute x as 0 in the substitution. So if I put x as 0, cos 0 will give you 1. And if I put x as pi, cos pi will give you minus 1. So the new limits will be 1 and minus 1. After that, we will differentiate this equation with respect to t. So derivative of cos x will give you minus sin x into dx, and on the right hand side we have dt. But we need only sin x dx. Therefore, sin x dx will become minus dt. So let us substitute the values of sin x dx as minus dt and the new limits of t, that is 1 and minus 1, in the given integral I1. Our I1 was integral 0 to pi 1 minus cos square x into sin x dx. Therefore, I1 is, the lower limit is 1, upper limit is minus 1, followed by 1 minus cos x was t, therefore cos square x will become t square. Again we have cos square x, that is t square, and sin x dx is minus dt. So minus can be written outside and we have dt inside. Now if we have minus sign outside, we can directly eliminate this minus sign by replacing the places of the given limits. As the property goes, integral a to b f of x dx can be written as minus integral b to a f of x dx. So let us use this property and eliminate minus sign. Therefore, I1 will become 1 to minus 1. We have 1 minus t square into t square dt. Further, we can multiply t square to both the terms. So I1 will be minus 1 to 1. T square into 1 will give you t square, minus t square into t square will give you t raised to 4 dt. On separating the integral, we have I1 is equal to minus 1 to 1 t square dt minus integral minus 1 to 1 t raised to 4 dt. Integral of t square will be t cube upon 3 and integral of t raised to 4 will be t raised to 5 upon 5, using the formula integral of x raised to n, which is integral x raised to n plus 1 upon n plus 1 plus c. So we have I1 as t cube by 3 from minus 1 to 1 minus t raised to 5 upon 5 from minus 1 to 1. On further substitution, we have upper limit as 1, so 1 by 3 minus the lower limit is minus 1, so we have minus 1 the whole cube upon 3 minus t raised to 5 upon 5, the value of upper limit is 1, so 1 raised to 5 will give you 1 by 5 minus minus 1 raised to 5 upon 5. Now minus 1 the whole cube will give you minus 1 only, and that minus 1 into minus will give you plus 1. Remember, whenever minus has an odd power, it will give you negative sign, and minus term having even power will give you positive answer. Here the power was odd, therefore we have a negative 1. Minus, we have 1 by 5, again minus 1 raised to odd power, so if the power is odd we have minus 1 again, and that minus into minus will give you plus 1 upon 5. I1 will be 1 by 3 plus 1 by 3 will give you 2 by 3, and 1 by 5 plus 1 by 5 will give you 2 by 5. This will give you 10 minus 6 upon 15, that is equal to 4 upon 15. So let us substitute the value of I1 in equation number 1. So our equation number 1 was 2i is equal to pi times integral 0 to pi sin cube x into cos square x dx, and this integral we have taken it as I1. So 2i becomes pi times I1, and the value of I1 is 4 upon 15. Therefore 2i will give you pi into 4 upon 15. Here we have 2 ones are, 2 twos are. Therefore the value of I will be 2 into pi, that is 2 pi upon 15. This is our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to our channel Ekeeda.